Welcome everyone. This is going to be our video number 6 for question number 6 of our sequence quiz number 1 review. I hope you guys got a chance to catch videos 1, 2, 3, 4, and 5. In this question, Sonia is cutting wire to construct a mobile. She cuts 100 inches for the first piece, 80 inches for the second piece, 64 inches for the third piece, and so on and so forth. Assuming this pattern continues, write an explicit equation for A sub n, or A at the nth term, the length in inches of the nth piece. Well, we can take a look and we'll see that maybe this is going to be a geometric or arithmetic sequence. Arithmetic was test first. So for arithmetic, we would take the second number minus the first number and set equal to the third number, which is 64, minus the second number, which is 80, and see if we get the same results. We see negative 20 does not equal to, in this case, negative 16. So definitely not arithmetic. Let's try now geometric. Geometric would be, in this case, we take the second term, 80, divided by the first term. Would that be equal to the third term, which is 64, divided by the second term, which is 80? And we see in this case that we get 0.8 or 8 tenths, 8 over 10, and this is 8 over 10, and it works out. So we see this is going to be a geometric pattern, geometric sequence, and we call this our R value. Our common ratio is going to be 0.8. Now you can leave it as 8 tenths or 4/5 you want to, but for our purposes we're using a decimal because later on. But it's okay. We want to express it as a fraction as well too. Okay, so we know our formula for the nth term of a geometric sequence is given to us as a sub n equals a1, the first term, times the common ratio, R value, which we just found, raised to n minus 1. So we're plugging in here. The first term is going to be 100. So we have 100 times 0.8 to the n minus 1 power. We can't leave it this way. All right? We want to take care of this difference of exponents here. So we had learned previously from our laws of exponents that if you have a base raised to the difference, in this case x raised to a minus b, this is equal to that base raised to the first exponent over or divided by that same base raised to the second exponent. So we can rewrite our 0.8 to the n minus 1 as 0.8 to the nth power over 0.8 to the first power. And that's what we'll do here. So a sub n is equal to 100 times 0.8 to the nth power divided by 0.8 to the first power. Now, we can take this 0.8 to the first power and divide into 100, because this 100 really is going to be 100 over 1. And so this can be written as 100 over 0.8 times 0.8 to the nth power. Now, what is 100 divided by 0.8? Well, let's take a look at a calculator here. And so we have 100 divided by 0.8. We get 125. So now we can write a sub n is equal to 125 times 0.8 to the nth power. And this will be our explicit definition for the nth term of this sequence. Okay, so really in this case, when we simplify things, we're really taking the a1 and dividing it by the R value. So it's almost like a1 divided by R times R to the nth power. Okay, so it's almost you can almost write as a secondary rule that a sub n equals a1 over R raised to the R times r raised to nth power. Okay? Now, the second question is going to have us use this rule. And we see Sonia has only 40 feet of wire to use for the project and wants to cut 20 pieces total for the mobile using her pattern. Will she have enough wire? Okay, well, in this case, we need to add up all the pieces. We have learned recently of a new formula for the sum of a geometric sequence, and we take it to be S of n. This is for geometric, not for arithmetic. Arithmetic has a different rule. Geometric has the first term, a1, times 1 minus the ratio raised to nth power, close parenthesis, divided by 1 minus the r value ratio. Now, we know a1 is equal to 100, and she wants to cut 20 pieces altogether, so n equals 20. So let's fill this in. So with a sum of 20 pieces, it's equal to 100 times 1 minus 0.8, because that's our R value, to the 20th power, close parenthesis, divided by 1 minus 0.8. On our calculator, we're going to type it in this way, 100, open parenthesis, 1 minus 0.8, raised to the 20th, close that parenthesis afterwards, then divide by, open parenthesis, 1 minus 0.8, mainly because then close parenthesis. Mainly because if we don't open and close parenthesis around 1 minus 0.8, the calculator will just divide the numerator by 1 and then subtract that quotient by 0.8, which is not what you want to do. You really want to divide by 1 minus 0.8, which is really 0.2. So we want to calculate 0.2 first, you can, but that's okay though. So let's take our calculator and find this value. So we have 100, open parenthesis, 1 minus 0.8 raised to the 20th power, go to push one side, close parenthesis, and now we're going to divide by, open parenthesis, 1 minus 0.8, close parenthesis. And this is how we approach this. Remember, again, put parentheses around the 1 and the denominator, 1 minus 0.8. We get 494.2353925. Let's see if the calculator can make us a fraction. Hit math, enter twice. Nope, it's too complex a fraction for my calculator. So it's about 494 pieces. Well, definitely at least 495 inches. So it's approximately 495 inches. Well, she has only 40 feet of wire. So we take 40 and multiply that by 12. That is 480 inches. So we see in this case that, yeah, she's short. So our response will be, in this case, oops, Sonia will not have enough wire to complete her project. She will be short about, let's say, 15 inches of wire. Okay, and we can find this again. We found the total amount of wire that she has, 4 to 8 inches. She needs about 495, not enough. Okay, I'll make this full page and take a look at everything here. Okay, ladies and gentlemen, I hope this was helpful to you guys. If you found this helpful, please give this video a like and subscribe to the channel. Make sure also to watch the other 5 videos, because I'm going to be picking 2 questions that will be very similar to these 6 videos, but you're not sure which ones I'm picking. All right, ladies and gentlemen. So, good luck. Good luck. Make sure to show all work. All right, and I'll see you in the next video. Take care.